Greetings team, and welcome into today's webinar, which is fire rated systems for interior and exterior timber, which will be presented by Blair Rouse from Fireshield. Welcome in, Blair.
Thanks, Rob.
Now, of course, today's webinar is the one that we postponed from last month, just due to a COVID situation. So we're now back on track. But the subject is one that does come up fairly often, certainly for us at Resene, and we do know that fire group ratings requirements for interior timber and timber wall and ceiling linings can be a bit tricky at times. So today's session should certainly provide some useful info for everyone. Before we get started, I'll do a quick bio on Blair, just because he likes hearing about himself. So,
not really, but go ahead.
Blair's worked within the industry for the past 25 years and comes from an architectural background himself, having run his own practice for over 15 years. He manages the Fireshield technical and specification group and heads the new product procurement and development area as well. He also runs Fireshield's Specifier Support Program, which was created to assist architects and ensure that the correct systems for fire compliance are specified. So it certainly sounds like you're wearing a few hats there, Blair, and I know what that's like and what that feels like on the end of technical lines. We should run for about 40 minutes on the presentation today, and that means that we will get time for some questions at the end as well. So please do fire them in as usual, and we'll try and get through them as best we can. Right, well, I'll just hand straight over to Blair to kick things off. I'm going to disappear. He's going to stay on screen, and I will see you at the end of Blair's presentation for a few questions. All yours, Blair.
Great, thanks, Rob. Hi, everybody. Thanks for coming along today. Rob's already done my intro, so I won't get into that too much detail. Fireshield, most of you would have heard of us and dealt with us. We specialise in intermittent coatings for timber, and now we've also got some other timber products which I'll talk about today. But as Rob said, today's CPD is about fire rating timber and construction. It's obviously exposed timber or linings, it's ceilings and walls, and some structural and some facade cladding as well I'm going to talk about today. And what we've done is we've broken it into the main three methods of fire rating. These timber products and group surface ratings, timber facade cladding, and structural timber, which is actually specific design, which I'll cover shortly. So we'll crack into it. Now we have some learning outcomes for today's preso because it's CPD. And what we've done is the learning outcomes are broken into the design phases that you'd go through typically in a project. Hopefully it helps you work through it. A lot of what we're talking about today, the fire rating side of it, it should be done by your fire engineer, but for you, it's good to have an understanding so you can question it or you can propose systems that you've heard of that you think could be included in your project. So a lot of what I go through does have a lot of building code fire compliance, but don't panic, you don't need to recall it all, that's for sure. If I look here at number one, the pre-design phase. So we want you to be able to identify the key factors influencing the impacts on project costs when fire rating your timber substrates. So knowing what it's going to cost you to coat or impregnate, and your spec requirements for fire rating the substrate and impact on the building design. So getting that spec right from the get-go is key. So number two is conceptual design phase. So as part of that is your fire report. So you want to identify the fire rating required for the substrate in the correct areas. So group ratings for interior and exterior, what are they? Fire rating, what fire rating is required for exterior timber cladding? Can I do it? And can I fire rate timber to give it a minute rating? So structural timber, which involves char rates. So for example, a 60-minute, we often get asked the question, I've got a timber post, I need to give it a minute rating, can you help me? And the answer is yes, we can. So those are the three groups I talked about at the start as well. The next, we've got the final design phase, and we want you to recognise the importance of the limitations of fire rating timber substrates, design considerations, which means, for example, when you're coating, can I take it to the timber to a floor that's tiled and will be mopped, for example? What damage am I going to get? And will it still be fire rated if that coating gets damaged? Things like that. So you need to consider that. And installations in the appropriate interior and exterior zones. What can go in the exterior of a building? What can be on the interior? A wet area, dry area, those sorts of things. And recognise why exterior timber or cladding may require a group rating or a type A facade rating. And lastly, we've got consent documentation where it all comes together. So the product building code compliance, what its requirements are and its certification. Can I use it for what I need to use it for? How do I convey the fire rating requirements for my project in the package? You know, who's doing what am I responsible for? And requirements for the consent package. What does the council want now for you to represent what you're trying to achieve in your compliance package? So we move on to timber compliance, or fire compliance for timber. And it all comes out of CAs too in the building code. Probably the most complicated section of the building code to understand, which is why we get fire engineers to do it for us, and then we just have to interpret that information. So on the right here, we've got the three groups. The group surface rating initially at the top there. Now that's internal and external timber surfaces only, and it's expressed as a number 1 through 4, which comes from a test. We don't just, release a product and say that's group 1 without testing it. It's all from testing. And then we move on to type A and type B in the middle there. And that is all about facade, timber facade, or doesn't have to be timber, any exterior cladding needs a rating of type A or type B, depending on where it's going. And then at the bottom, fire resistance rating, which is probably the one that gets confused the most. When people may be thinking they're talking about group surface ratings, they actually ask us for a 30-minute fire rating to timber, for example, or a 60-minute, which is hard to achieve, can be done, and I'll demonstrate that shortly, but it's only for specific design. There's no certified system currently available in New Zealand for structural timber ratings. Now, it would be rude of me to talk about fire without having you understand why timber actually burns. We have a fire engineer in our business, P. Olsen, who will be joining us for some Q&A at the end, but he insists that I pop this in here because it's all about fire. So on the left-hand side, there is the detailed description. On the right-hand side, it will probably take you back to secondary school science. So for fire to occur, we need an energy or a heat source, we need a fuel source, and we need oxygen. Those three things, we get fire. If you take out one of those, we don't have fire. So that's what we do with intermittent, for example. I'll sit on the surface when the fire begins. They expand and insulate the substrate behind. So they take away the fuel source, which then means that timber's not going to burn. We'll start with group surface ratings for surface linings, interior, and some people don't know about exterior for group surface ratings. We'll cover those. So, what makes surface fires so dangerous? They are faster growing, a lot of fuel, small compact spaces, there's less time to escape and higher fire risks. Now, group surface ratings are all about escape. Down the bottom here, what do the group surface ratings provide? Obviously, we want a slower growing fire, we want more time to escape, we want lower fire danger, okay? Now, in the building code, surface finishes or group surface ratings are under C3 AS1, and it's all about fires affecting areas beyond the source. So by that, we don't want fire spreading through an area where the source is in another part of the building. So we allow people to escape from that area by preventing it from catching fire for a period of time anyway. Buildings must be designed and constructed so there's low probability of injury or illness to persons not in close proximity to a fire source. You'll see that sentence over and over again through CAS2, and I'll cover that again shortly. That's what this is all about. Group ratings are there to allow safe escape, which is obvious. So we have them in public buildings, libraries, retirement houses, villages, churches, those sorts of things. And I've already said that a group number is a numeric representation of performance achieved during the certified test, which I'll cover in a sec. 1 to 4 I've already covered. 1 is the least combustible through 4, which is the most. Now, it does affect all materials requiring a rating, not just timber, and sprinklers can lower the rating, okay? But your fire engineer can help you with that. Here's how it works. So in the bottom is group 4, and at the top, group 1. So group 4 is the worst, pretty much tissue paper. It's going to look at fire and it's going to catch fire. Some natural cedars, interestingly enough, are group 4. They're very light. Balsa woods, those light timbers. Up to group 3 there, which is timber is inherently group 3. Pine, for example, is a group 3 rating. So quite often you'll be able to use a pine plywood, install it, we only need a group 3 and you're fine. However, when you want a group 2 or a group 1 above there, you have to take your group 3 timber and we have to coat it for you or impregnate it to give you the group 2 and the group 1, because timber on its own can't achieve that. So you can see that group 2 there reaches flashover after 10 minutes. At the bottom, group 4 was after 2 minutes, so already we've got quite a big difference. And it's only at 100 kilowatt heat source, whereas if you go up to group 1, we've got, it doesn't flash over after 10, which is the same as 2, but then we crank the furnace up to 300 kilowatts for another 10 minutes. And if it passes that, it's getting close to being equivalent to concrete or fibre cement sheet or even sheet metal. So it's a very onerous test. All materials go through the same, usually a 9705 or ISO 5660 test to achieve these. Now I've got here a couple of videos on the left, group 1, and on the right, group 3. And hopefully they're playing for you now. You can see the difference. They're in the same setting. Group 1 on the left, we're at 1 minute. Nothing much is happening, nothing's really igniting. Group 3, you can see we're starting to get some spread of flame. Along the left, we're sitting at 15 minutes and we've come to a standstill because it's not igniting, which is what our timbers or timbers with a group 1 rating will achieve. On the right there, the group 3 is still going. Even at 4.5, 5 minutes, everything's starting to go. And you can see now we're getting some serious build up and heading towards flashover at around 600 degrees. Here it is here, after 5 minutes. That's when everything combusts in that space. Not only furniture and linings, but unfortunately, human life as well. So that's where our motivation comes for group 1 rating, so we can save people's lives. Now, where there are exemptions to group ratings in your project, so when you're doing a space and there's timber, and then all of a sudden you have other timber elements, but they are exempt because we don't have to coat them all. Either they're small areas or they're areas that don't contribute to the fire load. Now you'll see an interesting one there in the middle at the top is handrails and decorative trim. For example, a good one is we've just done a handrail design for a hospital, and it was one of those deep 200mm handrails. Now, because it was more than 5% of the wall area it was attached to, it actually required a group rating, which we can do by impregnating the timber, but you shouldn't really use a coating on it with human oils, impact from the hands. It would wear off over time, so impregnation is the way to go. But that's the solution there. You can see there's a whole lot of different exemptions, but this is only for if your design is using an acceptable solution. So if the fire engineer has done a specific design, they'll have to consider these individually if they've modeled the design. Now, we can have exterior and interior group surface ratings, typically in escape paths and things like that, stairwells, balconies, soffites, and the like. So on the left there, exterior, you'll see we've got a balcony soffit. And what are our options to fire rate that exterior? So we can use a polymeric fire retardant impregnation. It's a bit of a mouthful, but wood safe exterior is our example of that. It's an impregnated timber. It doesn't leach and it can weather. You can use imitation timber products, which has been around for a while, vinyl wrapped aluminium or wood grain tile. And an important one to remember is you cannot use a clear intumescent coating. They simply can't weather in New Zealand, and they will turn white or cloudy and sometimes lose adhesion. On the right there, you'll see we've got interiors, which all of you would have probably dealt with before. Once again, what are our options? We can use the polymeric fire retardant impregnation or wood safe, imitation timber products again, wood grain tiles and the like. And in interior, you can use a clear intumescent coating, which ours is the timber clear system. Our building code, it's interesting enough, it obviously has durability attached to it. A lot of the building codes around the world don't, as we do. So even if you're able to install an intumescent clear coating in an interior space, do make sure that you're better to do that rather than the impregnation for certain reasons, because the impregnation, for example, cannot be damaged. Lasts the lifetime of the timber. Human impact, you can hit it, kick it, it's fine. Coatings always are susceptible to slightly more damage than the impregnated systems. Practical examples of group surface ratings. Here we go here, cafe if you like. You'll see that we've got timber ceilings. There, looks like a particle or strand board. They'll typically require a group surface rating if it's a public space. Here you could use an intumescent coating. Low impact zones, great. If it's dry, perfect. You could use impregnated timbers or an FR MDF board, which typically is on the back of a veneer, and unfortunately they're normally black or pink, so you probably wouldn't leave it exposed. You'll also see we've got a little couple of columns, structural columns there. They may be exempt from the group rating because, as per the previous slide, they're under 3 meters wide. So, yeah, you don't have to give us a group surface rating. Here we go for an external group surface rating. We've got a feet and a main exit way and a building actually here in Christchurch. And it will require a group surface rating, check with the fire report obviously. And if it does, how do we achieve that? Well, intumescent coatings we wouldn't use here, an exterior wet zone. The polymeric impregnated timber, absolutely we can use that here and we can also stain that. And artificial timbers are an option and have been pretty much your only option for exterior for some time. Timber claddings or facade claddings, the next subject for exteriors. Now, this is one that if you've been around a while, we used to be able to do over 10 meters, not a problem, but since 2017, things changed. So if I start there, what makes external surface fires so dangerous is obviously the fast external growth. You've all probably been hiding under a rock if you haven't heard obviously of Grenfell Tower and external fire and how dangerous they can be and how fast they can spread up the vertical surface. You have less time to escape and very high fire risks. Exterior timber cladding or type A is the surface. It's stopping the fire on that surface. You'll see here for 1st of January 27, there was a restriction on the use of combustible claddings, external claddings, and it was introduced into the building code. Now, the maximum height for timber clad buildings was limited to 10 meters at that point. So up to 10 meters, not a problem. You can put timber on it as an external cladding, but above 10, you couldn't. So as a result, timber was no longer used as an external cladding, okay, on buildings over 10 meters. There was no product that was able to do that for you. And for those of you that are a bit younger and wonder why some of the senior partners in the firms make you get things under 10 meters if it's got timber cladding on, now you know that it's all to do with that building code compliance. Things have changed though, which I'll get to in a minute. So C7 is the building code clause, which is fire again, affecting areas beyond the stores. Now type A timber, certified timber claddings using a fire retardant are also subject to a weathering test prior to the fire test. Now this is pretty obvious because we want to make sure that we weather test the impregnation in the timber and then we put it through the fire test. because obviously when we put it outside in the real world, it goes through weathering, and then if it's required to, it has to perform in a fire situation. Type A certified timber claddings must be fire tested, as I said before, to ISO 5660 or 3837, that's worldwide, so it's very common. And the entire cladding system must be type A rated, which I'll get to in a minute. So it's everything back to the timber frame, the internal timber frame. Now here, we often talk about having to do things and not actually understand why. So it's quite important for us to have a look at these C3 building code, the fire, the functional requirements of why we're doing what we're doing. So 3.1, now buildings must be designed and constructed. So once again, low probability of injury or illness, which is great, and person's not in close proximity to a fire source. So it's preventing that spread of flame we were talking about earlier. This is specifically for facades. 3.2 is very similar. Buildings over 10 metres where the upper floors contain sleeping uses or other property must be designed and constructed. So there's a low probability of external fire spread to the upper floors. So we want to stop, for example, if there's a dumpster fire outside a 7-storey building, we want to stop that spread of flame up that vertical surface. And lastly, 3.3, buildings must be designed so there's a low probability of fire spread to other property, either vertically or horizontally across a boundary. So that's where you'll see why the under 1 metre rule starts coming in. Here we have the timber cladding classification. Quite often you would have probably heard the term type A, but what does it actually mean? In the building code, it obviously has these peak heat release rates and total heat release figures. But in a nutshell, it's required in all buildings over 10 metres in height or within 1 metre of a boundary. Also, buildings containing risk group SI, which is sleeping institutional hospitals, some retirement homes, for example, require this. Type B below is a little rare. It comes up every now and then, but type A is the one you need to concentrate on. So as I said, in 2017, the building code pretty much outlawed timber as an option for exterior claddings over 10 metres. We didn't have a type A solution that could pass that test. So people would often come to us, can I use your intermescence, clear intermescence on my cedar cladding? No, you can't. Clear intermescence, not only ours, but all clear intermescence have difficulty dealing with UV and our weather conditions here in New Zealand. We have high wind, rain, humidity here, way higher than Europe. There's just nothing that will cope. Up till now, artificial timber systems, vinyl wrapped aluminiums, wood grain tiles were used. They did have the type A rating, but they weren't timber, so they had repetitive grain patterns and whatnot. Now we have got ammonium phosphate impregnated timbers available in New Zealand, but they are not type A rated. Ammonium phosphate impregnation systems typically leach once they get wet, and once they start leaching, that impregnation just continues to come out of the timber, and you'll see a sort of a salt finish. Looks like white salt on the surface. So what timber solution we have now is the polymeric fire retardant impregnation. It doesn't leach, so it's impregnated into the timber. It's also put through a kiln process, and it pretty much plasticizes into the timber surface to a 5 mil depth, preventing, it gives you the type A rating. So our new wood safe exterior is the only polymeric fire rated impregnation system currently certified type A in New Zealand, only available in cedar. We often get asked, what does it look like? It looks exactly like that board there. It looks no different from standard cedar. It gets delivered to site, the builder can then just put it up. You can also use it for a group surface rating, as I talked about earlier, in wet areas now, and anywhere you like. And it is compatible with Resene's range of stains, which we're currently testing in Wellington with them. We'll have those available in the next 3 weeks, I would think. Earlier on, I talked about the entire system requiring type A. Here's what you're looking at. So you've got obviously the type A timber cladding on the outside there, a type A building wrap or rigid board, so RAB or something similar, and a type A cavity batten. Cavity batten could be steel, in which case you need to screw fix to it, but we do have available a timber type A batten, which we also treat. Now it's important there that you also, on the right hand side, you'll see the words fire rated cavity closers. You need those in interstory junctions. You can, for example, install them as a simple intermescent strip tested system which expands. The idea there is to prevent the fire spreading up the cavity, which is exactly what happened at Grenfell. And we want to stop that fire at each story so it doesn't keep spreading up that cavity. A couple of examples of now what you can achieve. Here we've got obviously a timber type A on that outside face, and then probably a group surface rating, possibly on those balcony feet. And once again, vertical cedar there. Now you can go over 10 metres with that wood safe. This is an interesting one and slightly more complicated, so I'm going to do it with a practical project example for you. Structural timber. There is in New Zealand no certified test for compliance with the building code for a structural timber as such, like there is, for example, in Europe. So we have to do a specific design for you, but it can be done. So what does this apply to? So it applies to all CLTs or LVLs, glue lamps, for example, structural members that are exposed. You clad them in jib or whatever, fire rated jib, then you probably don't need to worry about what I'm about to talk about. But the standard for the design is 3603. And structural timber fire protection actually involves char rates or reduction of. So if you're doing a CLT building and you want to leave all the members exposed, typically your fire engineer in conjunction with your structural engineer will oversize those members to allow, let's say you want a 60-minute rating, they will calculate the char for 60 minutes and then whatever's left after that 60-minute event, fire event, it needs to be enough to offer structural stability to that building after that event. So they're not trying to stop it from catching fire, they're just allowing it to catch fire, but make sure that there's still enough in that column, for example, to hold the building up. Now, specific design is available for char rate reduction, so using a coating to slow that char down. And you see here an extract from 3603, the testing methods for this compliance pathway. Basically, there's a whole big sentence there, but what we're saying is that when we test the timber load-bearing element, if we coat it to slow the char down using a standard fire test, which is what we've done. So to bring this back to something you actually understand, I've done it, it's an actual project we've done. So it's an historic project, a multi-story project in New Zealand. And they wanted to basically have existing exposed structural timber members plus the floor needed a 30-minute FRR. And often you'll see what I've got in the brackets there, 30 dash dash. So 30, that first 30 is structural, then installation and integrity. So we only require the first at the structural. What are the options for the designers that want to leave that exposed so they can see it as part of their office fit out or whatever? So you could clad it in fire rated boarding, which defeats what they're trying to achieve. You could use natural NZS 3603 char rates, or you could protect with intermescent coating to reduce that natural char rate. So just quickly, the 3603 char rate is 0.7 millimeters per minute plus a 7 mil allowance zone for any error, let's say. So for 30 minutes at 0.7 mils is 21 millimeters off each exposed face. So if that floor up there is 30 mils deep, you're going to lose 21 mils plus 7, 28 mils. So you've got 2 millimeters of floor left after it's charred. Can you walk on that? Well, the simple answer is no. Now down here, design considerations required for the specific design. What else do we have to do to make sure this can work for the architect? So we can seal it to floorboards, which means we don't want fire getting through those existing floorboards. We have to seal them. The tongue and groove protection, we need to examine that to make sure that that's not going to be affected in the fire. What are the penetrations actually into the joists? We don't want to create a heat sink where we're actually defeating the purpose of what we're trying to achieve. And floor penetrations for vertical stacks. How do we achieve that? through that building and that protected floor. Here's the solution for this example. That's what they wanted to look like. Loft style, exposed ceiling, exposed floor, underside floor joists and supports. So we were able to reduce the natural char rate of the timber using our timber white coating. We reduced it, as I said, from 0.7 mils a minute or 28 mils, and we reduced it to 8 mils. So 8 mil of char off all those members was enough to, after a 30-minute fire event, 8 mil of char, the remaining timber member was able to give the structural stability required to support that floor still, which is what they needed to achieve. On the right-hand side, you'll see a diagram about how the cross-section looks after a char study, for example. Now, our solution uses our laboratory structural timber testing and evidence, and it was accepted by the Auckland Council. But we issue our own PS1 and PS4 for our own design, because we have a fire engineer on board, and we're able to do that for you, which is important. Now, as part of what we did, we had to obviously, like I said before, reduce heat sinks and how we do vertical stacks. So on the left there, how did we attach, for example, sprinkler or HVAC to floor joists? Well, we introduced extra blocking and the fixing went through the blocking. You know, we didn't want to create opportunity to fire to get in there and defeat what we were actually trying to achieve. On the right-hand side there, we had to use, for example, here, the jib vertical ceiling system to allow us to get our stack through and into the floor above. But that was only in small areas, you know, hardly noticeable, like a small bulkhead in the exposed floor, so it wasn't detrimental to the design. Now, these are all our products that we use to achieve what I've been going through. Our timber clear on the left there, timber white, and a new one, timber whitewash. We also have available our spec sheets, our system spec sheets. Now, we give those to you. They often, they're all involve Resene products. They're all approved to be used with Resene products in our systems, such as Colorwood can go under our timber clear, for example. And obviously, the Resene range will be used with our wood safe. As I said before, our exterior facade system for Type A is wood safe exterior. We're very excited about it. It's cedar only. And then obviously we've got a lot more timbers also available in wood safe interior dry space. But there's about 10 to 12 timbers that are tested. They all have to be tested, unlike an intermesson where we can put the intermesson onto a timber substrate that is a minimum thickness and density. With these timbers, we have to actually have tested the species, which we do. So wood safe exterior can also be used in wet area group surface rating situations, and we have case studies that you guys can give us a call and we can get out to you. And I think I've managed to get through that pretty good, Rob, in the end.
Yes, that was outstanding. Thanks, Blair. There's a whole heap of information in there, and I'm pretty sure that most people viewing are going to want to watch that again. So we have had a few questions come through about where the recording will be, and it will be up on our website in a few days for all to view at any point. I know for a fact I will be going back through that probably more than once, as it was some outstanding information in there for the industry. We do have some questions. We had some questions come in earlier, and we've got some come through today now live as well. So we'll crack straight into them. And I see Pierre's joined us there, so welcome aboard.
Yeah, that's right. Yeah, I can just introduce you. I can't see my camera, unfortunately, but yeah, Pierre has popped in. He's going to figure it out. No, you have to keep showing my screen. Yeah. Oh, okay. Right. Yeah, there we go.
There we go.
So Pierre's a fire engineer, and he'll help us with any really technical questions. So you get some free fire engineering advice today.
Right, I will crack into a couple that came in earlier, and it's around the application of the intromescent. Is it better to apply it off-site or on-site?
Yeah, that's a good question, and it is pretty much project specific, depending on what you wanted to achieve. On-site, the advantages are the timber's there. You can see what the area you're dealing with, but the disadvantages, obviously, we need to control that space for 48 hours. So sometimes it's masking off the area. Off-site, the advantages, you need to be doing it ahead of time. So the product takes about 2 to 3 weeks to harden. So we need to make sure the main contractor is aware of that, and we can get it done for them and get it delivered on site in a timely manner. But really, they're pretty much much for muchness.
So another question leading on from that is, can you touch up intumescent coatings applied on site?
Yeah, you can. We have a maintenance guide which we submit with every consent package, which gives guidance on what you need to do. For small damaged areas, you've still got your group surface rating compliance depending on the amount. I think it's 5% for the fuel cell we're allowed to have non-protected. So while visually it might not be that pleasing, it still has compliance. But for larger areas, yes, we can. And our registered applicators just go back to site and do the repairs for you.
Excellent. Now, I think you touched on this, I'm pretty sure you touched on this through the presentation, but we've got one around wet areas. So which Fireshield product is most suitable for wet areas?
I want to go with that one.
There'll probably be no intumescent. The water-based intumescents are quite hygroscopic, so although we do have some top coats that could be used in wet areas, our recommendation would be wood-safe exterior. So the impregnated, polymeric impregnated timber that we use for our facade claddings can be used inside in completely wet areas and 100% humidity. Obviously, it can sustain direct rain exposure. So a good choices for pools and other wet areas, probably even a sauna if you want to have it in there.
One thing I didn't cover, I'll just quickly cover, is with the exterior facade claddings, the impregnation doesn't give you the durability B2 requirement that you also need to achieve. So that's where the facade timbers are limited to timbers that are able to get natural durability in 3602. So cedar, larch, spruce, those sorts of timbers. We can't combine an impregnation with an H3.1 treatment. We can do it on abodos and things like that, heat treated pines, but we need to test that. So those things are ongoing. But so what Pierre's saying is correct, that we can only do certain things in wet areas, but you also need to consider your timber durability as part of the spec.
Excellent. Now, I think that's just answered a question that came in from Tammy Mullins on that one, is why only cedar for the exterior?
Yeah. So that's a really good question, and it's all to do with 3602 natural durability. We are looking at other exterior timbers, yellow cedar, larch is on its way, Akoya will be here shortly, but unfortunately pine, as I say, needs that 3.1 or 3.2, which we can't have additional to the impregnation.
We'll stay with the wood safe. There's a question coming from Hugh Parslow here. Does the externally used polymeric treated type A cedar still silver off, or does the impregnation and heat treatment seal the native color of the cedar for the life of the product? That's an interesting one. Everyone's always wanting the look of that, the timber to remain. So I'll let you address that one.
You got it. Well, it does silver off. So the polymeric treatment does slow the process down. So which could be an issue if you have on the same facade you have a wood safe exterior cedar next to a non-fire treated cedar, because they age slightly differently. It does extend the durability of the cedar, but it does grey off. So if you want to maintain that look, or whatever stain you use, you have to keep restaining it. So treat it basically like you normally would with a cedar cladding, with an expectation perhaps that it age slightly slower.
Yeah. So for example, we're working with Hermpack on some exterior cedar options and using wood eggs, things like that, and woodsman for exteriors.
Sure. We've had a question come in as well, which is an interesting one. It's one we get quite a lot, is around decorative paints. Do they have fire ratings themselves? It's probably one I can answer, but I'm sure you get asked it a lot as well. And I'll give my answer, and then you can correct me if I'm off the mark. But in simple terms, Decorative paint coatings and clear coatings, if they're applied at their normal specified rates, don't add or detract from the substrate's own fire group rating. So essentially they're inert. They don't change the fire group rating of a substrate. And so the one that we get asked a lot on is always timber wall or ceiling linings kind of thing. And our answer is always no. You need an intumescent coating if you've had a requirement for a Group 2 fire group rating. So
yeah, sounds bang on.
Yeah, it's probably get a little more technical when you get to Group 1 and 2, but for Group 3 you are correct. When you get up to the higher group ratings, we have Resene's products that we have tested and they work really well. We have tested some other paint products where in theory they could add to the smoke reduction rates, which is sometimes required at Group 1 and Group 2, but when you get into Group 1 and 2 on timber, you do need an intumescent that works and are compatible, for example, with the Resene product range.
Yep, and often, unfortunately, occasionally it's an area that might be missed by a specifier or on a project, and we often get asked the question when there's a bit of a scramble going on, I guess, and when someone's picked it up, and unfortunately, there is a difference, I guess, in cost per square metre of decorative paints versus intumescent coatings, which is usually where the problem is starting to escalate for specifiers or project managers, I guess.
Yeah, so as an example, in our system spec sheets, we have a number of approved Resene top coats, and they are there. This is when you need to use an intumescent. So timber has a group rating of 3, and if you need to get a 2 or 1, you need to have an intumescent to protect the timber. But you have to use an approved top coat, because if, for example, we use a high tension polyurethane sealer on top of our top of our intumescent, the intumescent will not expand. You get too much tension, and they can produce too much smoke. So we have fire test failures on some top coat systems. So it is important that it is a system.
Mm-hmm. Now, a question from Natalie Snowden. Thank you, Natalie. Can you talk about veneers on fire-rated substrates, things that we need to keep in mind?
Our experience is that, I guess, veneers on fire-rated substrates will have their own testing for group surface ratings. We've found that with a Group 1 FR board behind them, they might achieve a Group 2 if the veneer is a hardwood. But having said that, if you cannot get that from that supplier, our coatings can be used on multi-layer substrates, so plywoods, timber veneered, MDF, for example. So what you could do is, if you're in a Group 2 and you need a Group 1, well, you could go right back and get a substrate, for example, MDF that wasn't fire rated, save some money there, put the veneer on it, and then we can coat it, get you from a Group 3 up to a Group 1. We also will have available soon, impregnated veneered plywood. So there's no coating required. We just supply the impregnated board from the get-go with the veneer on it.
Very good. Now, just a question from Craig Gregg here around the 10 metre or above buildings. Are soffits and fascia considered claddings in the building and therefore require fire rating? I think you touched on that a little bit in the presentation.
Well, strictly, it depends. It's a feat. Probably isn't a cladding, but different fire engineers will have different interpretation of that. The fascia board probably would be part of the cladding. You could have timber expression elements on a balcony that is not part of the cladding, but my expectation is probably you will find that in a building over 10 metres in height with timber on the facade, whether that's soffit or balconies or fascia, the fire engineer will require those to be fire rated, just because of the add to the total fire risk.
That's a good question.
Very good. Actually, a question on WoodSafe here. What's the cost difference between WoodSafe and clear intumescent? Also, what's the lead time for impregnation?
Good question. So with the pricing of WoodSafe, once you have the substrate for intumescent, labour and the intumescent itself, WoodSafe is the same price. So there's no price difference, substrate and WoodSafe. They're the same. And the lead time currently, we're looking, thanks to the worldwide construction boom, probably 4 to 6 months currently lead time. But once you're writing a spec, we get involved early and make sure we're starting to get things rolling for you. So just as long as we're here nice and early currently, then we'll be fine. But it's just all due to timber shortages currently.
Another WoodSafe question, actually. This is a popular product.
Yeah.
Do you coat any supplier's product with WoodSafe, with the only requirement being cedar species?
Yeah, no, good question. So we're currently working with Hermpack and their range of profiles, and their vertical and horizontal systems for exteriors. But having said that, if you find a different profile, then it can be done. The important thing to remember is that the board needs to be profiled before we impregnate it. So we can't, for example, impregnate raw cedar and then have it profiled. But yeah, any profile is available. And it's important to remember it's not actually a coating, that it is impregnated into the timber and then put through a kiln and baked in, basically.
Now, another question, this is slightly different. Can you confirm that RAB board is acceptable? We have projects where fire engineers required us to move to an alternative, and they've given jib weatherline as the alternative there. So I'm not sure if that's a question for you, but you may want to attempt an answer.
Yeah, definitely a question for a fire engineer. I think it depends on the context of that question, because it's a bit difficult to answer without actually knowing the detail. I'm assuming you it's probably maybe it's an email to me after the presentation.
Absolutely.
We'll follow up on that one. That's we'll follow up on that one. That's fine. So, look, I think that brings us pretty much to a close today. As I mentioned after the presentation, there's a whole lot of information I think that we're all going to need to go back through and re-watch your presentation, Blair. So thanks very much. It was extremely informative and certainly topical in the industry. And we know for a fact on the end of our technical lines, we get a lot of calls around fire group ratings and timber interior wall and ceiling linings. So excellent topic, and very much appreciate your time today presenting for us. As I say, we'll leave it there. As mentioned, the recording will be up in a few days, and anyone that's asked a question that we haven't got to, we will come back to you and answer directly in the next few days. So thanks again, Blair and Peter. We really appreciate your time, and we'll see everyone at our next webinar. Thanks for your time.
Thanks, guys. Thanks for coming.